Acid, base, and salt. Acid, base, and salt. Hydrochloric acid HCl acid, sodium hydroxide NaOH base, sodium chloride NaCl salt. Acid, base, acid base indicators, natural indicators, synthetic indicators. Olfactor indicators, universal indicators, organic acids, mineral acids, bases, chemical properties of acids and bases, reaction with metals, reaction of metal carbonate and metal hydrogen carbonate with acids, test of carbon dioxide, acid and base water solution, current conduct electricity, dilution of acid, neutralization of reaction, pH scale, importance of pH scale, Chalor alkali process, bleaching powder, images of bleaching powder, baking soda, when baking soda is heated, uses of baking soda, washing soda, uses of washing soda, plaster of Paris, uses of plaster of Paris, some other salts, acid. An acid is an acid is any hydrogen containing substance that is capable of donating a proton hydrogen ion to another substance. An acid turns blue litmus red. Red means danger. Trick. It is usually identified by their sour taste. Base. A base is a molecular ion able to accept a hydrogen ion from an acid. A base turns red litmus paper to blue. Acid. Blue to red. Blue litmus turns red and base. Red litmus turns blue. Acid base indicators. Natural indicators: litmus, extraction of lichen, talophyte, turmeric, natural dye curcumin is present in it. Colored petals of hydrangea, petunia, geranium, red cabbage, China rose. Synthetic indicators: phenolphthalein, methyl orange, turmeric, neutral. Turmeric, it remains yellow, neutral. And acid in turmeric, turmeric plus yellow, it remains yellow. Base, turmeric plus lime, it turns vermilion. Litmus is a purple dye which changes its color when interacted with a acid or base. Litmus, acid, base. Okay, litmus, blue to red in acid, in base red to blue. Turmeric in acid remains yellow, in base turns to reddish brown. Phenolphthalein in acid colorless, in base pink. Methyl orange in acid red, in base yellow, a bit orangey. Olfactory indicators: those indicators which change their smell when mixed with an acid or basic solution. Mixed with an acidic or basic solution. Example: vanilla, onion, clove. Olfactory indicators: onion remains smell, acid and base. Onion in acid remains smell, in base loses its smell. Vanilla extract in acid remains smell and in base loses its smell. Clove in acid remains smell and in base loses its smell. Universal indicators: neutral between 7 and 8, green dark green, and from highly acidic and purple highly basic. And pH scale 1 to 14 is 1 red, 2 pink, 3 orange, 4 beige, 5 yellow, 6 green, light green, 7 normal green, 8 dark green, 9 turquoise, 10 pale blue, 11 blue, 12 dark blue, 13 violet, 14 purple. A universal indicator is a mixture of different types of indicators that exhibits different coloration at different levels. It is useful to detect the acidic or basic nature of a substance or a solution. Organic acids. Acids that are derived from plants and animals. Acid and source. Acetic acid, vinegar. Citric acid, citric fruits, lemon and orange. Tartaric acid, tamarind, grapes, kacha mango. Oxalic acid, tomato, spinach. Lactic acid, curd. Ascorbic acid, citrus fruits, amla. Methanoic acid or formic acid. Ant sting, nettle sting. Butyric acid, rancid butter. Stearic acid, oil or fats. Malic acid, apple or banana. Mineral acids. A mineral acid or inorganic acid is an acid derived from an organic compound that dissociates to produce a hydrogen ion H plus in water. Acid sources sulfuric acid, king of chemicals, because it is highly reactive, corrosive in nature. Sources oil of vitriol, nitric acid, explosives, hydrochloric acid, gastric juice, boric acid, antiseptic, carbonic acid, cold drinks, phosphoric acid, fertilizers. Bases, base sources, calcium hydroxide, lime water, ammonium hydroxide, window cleaner, sodium or potassium hydroxide, strong base, soap, magnesium hydroxide, mild base, milk of magnesia. Chemical properties of acids and bases. Reaction of metal. Acid plus metal gives salt plus hydrogen. Salt M plus A gives S plus H. That is metal plus acid gives salt plus hydrogen. Hydrogen bonds with a pop sound. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Zinc plus sodium hydroxide gives zinc sulfate dioxide plus hydrogen. Reaction of metal carbonate and metal hydrogen carbonate with acids. Metal carbonate or metal bicarbonate with acid gives salt plus carbon dioxide plus water. Sodium carbonate or sodium bicarbonate plus hydrochloric acid gives sodium chloride plus carbon dioxide plus water. Test of carbon dioxide. Carbon dioxide turns lime water milky. Calcium hydroxide, lime water plus carbon dioxide gives calcium carbonate, white PPT. Turns lime water milky plus water H2O. Acid or base in water solution. Conduct electricity. Aqueous solution of acids. H plus or H3O plus ions. Aqueous solution of base. OH minus ions. Hydroxyl ion. Distilled water. Alcohol and glucose do not conduct electricity. All bases do not dissolve in water. An alkali is a base that dissolves in water. An alkali is a soapy to touch, bitter in taste, and is corrosive in nature. All alkali are bases, but all bases are not alkali. Dilution of acid. When diluting an acid, it's safer to add acid to water slowly and with constant stirring than to add water to acid. Adding water to acid can cause an extreme endothermic reaction that produces a large amount of heat, which can cause the solution to boil, splatter, and cause burning. Concentrated to dilute. Always add acid to water, right, and not water to acid. Neutralization reaction, exothermic in nature. Acid plus base gives salt plus water plus heat. Acid and base gives salt plus water. Image. Metal oxide basic plus acid gives salt plus water. Non-metallic oxide acidic plus base gives salt plus water. Strong acid plus weak base gives salt acidic plus water. Example: aluminum hydroxide plus hydrochloric acid gives aluminum chloride acidic salt. Weak acid plus strong base gives salt basic plus water. Example: acetic acid plus sodium hydroxide gives uh, sodium acetate basic salt. Strong acid plus strong base gives neutral salt, gives salt or neutral. Example: sodium hydroxide plus hydrochloric acid gives sodium chloride or neutral salt. Weak acid plus weak base gives salt or neutral. pH scale. P stands for potence, means power in German language. Developed by Lauritz Sorensen, a Danish chemist. Universal indicator 0 to 14. It is a mixture of several indicators. It shows different color at different ion concentration. It is a logarithmic scale. It measures H plus ion concentration. P directly proportional to 1 by H plus. pH and pOH scale. Low pH value indicates strong acidic. From 7 to left side, increase acidity, and right side decreasing H plus, middle neutral, and from 7 right side increase basicity, and towards left side decreasing OH, and 14 high pH indicates strong base. pH is equal to minus log H plus. pOH is equal to minus log OH minus. pH scale 0 to 7 acid, 7 to 14 base, 7 neutral water or distilled water. P is inversely proportional to H plus ions. Important pH values: gastric juice 1.6, lemon 2, milk 6.4, blood 7.4, slightly alkaline, saliva 6.5, milk of magnesia 10, sodium hydroxide 14. Importance of pH scale in everyday life. Human body works under a pH range of 7 to 7.8. Use in use in treatment of soil. Quicklime or calcium carbonate, slaked lime is added to acidic solution. When soil is basic, then gypsum is added to treat it. Antacids like magnesium hydroxide, baking soda, aluminum hydroxide to treat indigestion when stomach produces too much HCl. Used for self-defense. Bee sting. Remedy. Apply milk base like calamine, zinc carbonate. Sting hair of nettle plant. Acid rain. Having pH less than 5.6. SO2 plus NO2 oxide. Tooth decay starts when pH value is less than 5.5. Dock leaves. The cooling sensation of dock leaf juice may relieve the burning. Stinging sensation caused by nettle plant. Chlor alkali process. When electricity passes through brine, it decomposes to form sodium hydroxide. The process is called chlor alkali process. Chlorine coming outside and sodium chloride getting inside, 24% sodium chloride outside. Hydrogen coming outside, H2O inside, and sodium hydroxide outside. Legend. Input output membrane chlorine sodium Cl2 H2O. Okay, Cl minus Na plus Cl2 H2O OH minus H2. Sodium chloride aqueous plus H2H2O gives 2NaOH plus Cl2 plus H2. Sodium chloride. Aqueous solution of sodium chloride is known as brine. Sodium hydroxide at cathode and chlorine at iodide and hydrogen at the cathode and Cl2 at anode. Here, chlor stand for chlorine and alkali stands. Here, chlor stands for chlorine and alkali stands for sodium hydroxide. Bleaching powder, calcium oxychloride, calcium oxychloride, calcium hypochlorite. Chlorinated lime, produced by action of chlorine or dry slaked lime, CaOCl2, CaOH2, slaked lime, plus Cl2 gives CaOCl2 plus H2O. Uses of bleaching powder. Textile industry for bleaching cotton and linen. Paper industry for bleaching wood pulp. For bleaching wood pulp. In laundry as an oxidizing agent in chemical industry as disinfectant for cleaning drinking water. Baking soda, sodium bicarbonate, sodium hydrogen carbonate. NaCl plus H2O gives CO2 plus NH3, that gives NaHCO3 plus NH4Cl, that is sublime compound. When baking soda is heated, 2 NaHCO3 gives Na2CO3 plus H2O plus CO2. Uses of baking soda: tasty, crispy pakora, and faster cooking. To make baking powder, mixture of baking soda plus mild edible acid and antacid substances when neutralize stomach acidity. In soda acid, in soda acid fire extinguisher, dilute H2SO4 plus NaHCO3. Here nozzle, okay. Soda acid fire extinguisher, nozzle, tube, knob, sulfuric acid in glass bottle, sodium bicarbonate solution, metal cylinder. A soda acid fire extinguisher is prepared by filling a strong iron vessel with a solution of sodium bicarbonate, baking soda, and storing sulfuric acid in a separate settled bottle inside the extinguisher. When the fire extinguisher's knob is turned, the sulfuric acid and the sodium bicarbonate react to produce carbon dioxide gas. Washing soda, sodium carbonate, Na2CO3 into 10H2O. NaHCO3 gives Na2CO3 plus H2O plus CO2, and Na2CO3 plus 10H2O gives Na2CO3 into 10H2O. Uses of washing soda in glass, soap, and paper industries. In manufacturing of borax, Na2B4O7 into 10H2O. Cleaning agent in removing paper ma- paper in removing permanent hardness of water. Hard water, water that contains high levels of calcium and magnesium minerals. Heavy water, a type of water that contains a higher concentration of deuterium or D2O, a heavy isotope of hydrogen than regular water. Plaster of Paris, on heating gypsum at 373 Kelvin, it loses water molecule and form plaster of Paris. CaSO4 into half H2O, calcium sulfate hemihydrate. It is a white powder, and on mixing with water it changes to gypsum. CaSO4 into half H2O plus 3 by 2 H2O gives CaSO4 into 2H2O. Use of plaster of Paris for supporting fractured bones, for making toys, decorative material, smooth surface of walls. Note: it is always stored in a moisture-proof container as it absorbs moisture to form hard gypsum. Some other salts: blue vitriol CuSO5 into 5H2O can be used to help relieve mouth ulcer. Green vitriol FeSO4 into 7H2O. White vitriol ZnSO4 into 7H2O. And Morse salt NH4 taken twice, FeSO4 taken twice into 6H2O. Alum KAiSO4 taken twice into 12H2O. Epsom salt MgSO4 into 7H2O. Anhydrous CuSO4 is white or pale green in color and has a powdery appearance.